everyone, it's Susan Seiler here doing Cycle 2 Week 14 Science. This week we have two science experiments, number 165, cold foot or cold hand, and number 171, pepper run. CC Livermore tutors for cold hand, cold foot. We're going to be doing this outside on the concrete in front of the Family Life Center, and the pepper run experiment will be on a table in the Family Life Center. Okay, so let's get started. Hi, all right. So what are we discovering? We're discovering conductors of heat. What is a conductor? You can find this information in the Y section of your Van Cleve's book. It's actually also on the bottom of your science note sheet, just because I found this one to be confusing at first. So a heat conductor is material that allows heat to move through it. It feels like we're feeling the cold, but indeed it's the heat leaving our hands, and that's why it's called a heat conductor. So the purpose, which is a better conductor of heat, metal or fabric? Which one will move body heat through it more quickly? How are we going to find this out? We're going to use a piece of carpet, we're going to use a piece of aluminum foil, and we are going to use the hard concrete surface out in front of the Family Life Center. What's our procedure going to be? We're going to have a piece of foil and a piece of carpet, and we're going to set them out on the concrete, and we're going to feel them. Which one do you think will feel colder? And that's the student's hypothesis. So have them go ahead and mark, what is their guess that will happen? Will the metal feel colder, or will the metal feel warmer than the carpet? So let's go ahead and go into the experiment itself. So have your students rub their hands to warm them up. This was Valerie's idea on a way to create friction to make more body heat. If it was me, I would mark in my tutor sheet, my science notebook sheet, between step 2 and 3 to have them rub their hands to warm them up. So have their hands, rub their hands to create some body heat and warm them up. Our students learned about friction last week in week 13 with the finger on top of the rim of the glass. So hopefully this is a concept that will be familiar to them, how friction can create sound. Friction can also create heat, and that's what we're going to be doing. Then I would rotate them in pairs or groups of 3 if you have 9 to put their hand onto the aluminum foil and onto the carpet and feel which one feels colder. Then they can write or draw. I would have them write some words in their observation. They may want to see if they rub their hands for a longer period of time or a shorter period of time, or after it's already been cold, if they rub them longer. I think this is going to be kind of a quick one. I'm trying to think of ways to make the experiment a little bit more in depth, but that's really the gist of what they're trying to do. At this point, after they've noticed what their observation is and made their conclusion that metal is a better conductor of heat than carpet, one thing you can talk about is what material pots and pans are made out of, what material jackets are made out of. Do we use a metal spoon or a wooden spoon for cooking, and why? Just to demonstrate to them that this concept is applicable in their everyday lives. That if they have a wooden spoon, when mom's cooking with a wooden spoon, she doesn't need a pot holder for that. But if she goes to grab something metal, a metal spoon, or even the handle of the pot that's metal, oftentimes she'll need a pot holder for that. And of course, we wouldn't wear a jacket made out of aluminum foil when it was cold. There's a reason that we would use fabric instead of metal. Okay, does that make sense? Really, really simple. So this is already going to be set out for you, CC Livermore tutors. It's already going to be outside, so you do not need to let it remain undisturbed for 10 minutes because it will already be undisturbed for 10 minutes. So hopefully that makes sense. Good. Okay, on to number 171, pepper run. We are going to have a container of water, a container of dish soap, and each tutor is going to have a baggie of supplies. When you are done with the experiment, please throw away the items that were in your baggie of supplies, and the next tutor, please grab a fresh baggie of supplies. So that way everyone has fresh supplies and it's all nicely contained. All right? So, what are we going to discover? Surface tension. Can we make black pepper run across a bowl of water, or can we weaken surface tension? Yes, let's find out. Okay, we need a water. We need water, a bowl for our water, pepper, which will be in these things. I'm going to use this for demonstration purposes. Dishwashing liquid, a container for our soap, and a toothpick. Perfect. Pour water into the bowl. I would pour it about halfway. It doesn't need to be all the way full. Whoops, that's about 3/4. That's fine. Sprinkle pepper over the surface of the water. So I would suggest your student maybe even just use half of their packet. They can use all of it. I don't really know how much is in a packet, and I don't want to use it. But you know, just to sprinkle it over the surface of the water. I don't know that you're going to be able to see this. Let me see. Can you see that? No. Let's see. There we go. Sprinkle it over the surface of the water. Then the experiment to me really has two steps, two tests per se. And this is a great one for observation. Observation truly is the grammar of science. Let our students spend a good amount of time here. So they see the pepper on top of their water, and the question is, what would happen when we put a dry toothpick in the water? What do you think is going to happen to the pepper? And the pepper is going to run. Nothing's going to happen. They have no idea. Have them select something on their sheet and then do it. What does it look like? Well, some pepper stuck to the toothpick, but other than that, the pepper looks exactly the same. We'll also have some napkins. There we go. Okay, so let's put some dish soap in here. There'll probably be a container. Oh no, there won't be. So just put some dish soap in there. Take the toothpick, dip the end. You just need a little bit. And then dip. What do you think is going to happen when we dip in here? Most of them will probably just guess that the pepper will run, but let's find out. And they dip. You know what? Hold on. Before moving on to this part of the experiment, and it's going to be a little bit of back and forth, however, I think it's really important, since this is the purpose, is this observation, to take the moment and to have them make dots for the pepper on what the pepper looks like. So after they add the pepper and after they use the dry toothpick, it should look very much the same. Have them go ahead and put the marks in there. Okay, now let's dip our toothpick in. And when they dip it, and if they just touch the surface of the water, it might go a little bit, and as they dip down a little bit further, the pepper will really move to the side. Oops. Oh. Well, you guys saw it in the tutor meeting, but the pepper moves from the center. When I moved it, it kind of went back in the middle, but it moves from the center to the outside edges of the cup. And have your students draw that. Have them go ahead and make dots for the pepper in their notebook, and then draw their conclusion about weakened surface tension causing the pepper to run. In the Van Cleves notebook, or in the Van Cleves book, again, it goes into detail about surface tension, and so that would be really good for you guys to read, to have some information about. But basically, surface tension is like skin. It's like a skin on top of the water, and when we break the skin, it moves out to allow allow more water to come up to form another skin, and that's what causes the pepper to move towards the outside edges. Okay, so that's that. Super easy experiments this week. I hope you enjoy them, and thanks for watching. Bye.